Hi guys. So today we will be solving today's problem of the day. So I have already recorded this video, but my voice was not clear in that one, so I am re-recording it. I will be explaining the code and my approach this time instead of rewriting everything, because this is an easier problem. You probably won't be needing the implementation. So today's problem is all about finding unique missing numbers from a given array, wherein we know the smallest and the largest element in the array. So what I mean is by this is, suppose you are given this array 2 5 1 3 6, and if we investigate this array, we will find s as the smallest element and l and 6 as the largest element. And so between this 1 and 6, if we proceed in ascending order, we will see that 1 2 3 5 and 6 elements are present. Out of these, 4 is absent, so 4 will be our missing element answer. Okay, so this is all about it. We need to return the answer in the shorted order of missing elements. Cool. So since the constraints are less in this one, we can see the constraints are only 100. So we can usually use a simple brute force of hashing, wherein we will have an array of 100 size elements. We will mark the imprint of every element on array index, and then we will traverse from smaller to the largest element, and wherever we are not able to find any imprint for a given element, then that will be one of our missing number. And since we will be traversing from smaller to largest element, the result will be in the shorted order. Another approach that I can think of is by shorting. If we short this element, then the 0th index element will be smallest and the n-1 element will be the largest, and we can simply continue the same thing. We will check for next element by incrementing previous element by +1, and if that element is present, we will continue. Otherwise, that we will capture that element and mark it as a result, as a part of my result array, and we will continue this until unless our largest element is not present. But the time complexity of this approach will be n log n. Meanwhile, our previous hashing one approach will be O of n only. So although with some constant space, in our case 100, so that doesn't matter. So yeah, so pretty much brute force will work here. Let me give you a walkthrough about the code also. So in code, as we discussed, we maintain a frequency element of 100 sites. We traverse all of our element and find the smallest and largest element, all also marking the imprint for that element as in true or false. And since we are trying to find the smallest element, we have initialized it with the largest element possible. Since the range is till 100, we have initialized it with the 101, and for the same goes for the largest element. We see the range starts from 1, we have initialized it with this with the 0. Yeah, then after that, we kind of make a for loop from smallest to largest element, and wherever the element is not present, is not imprinted, we took we push that element in our result array, and we return that result array. And since we are traversing from smallest to larger element, so this will always be shorted as required by our question. Yeah, so let me resubmit it one more time, and this is passing. Okay, cool. Yeah, so that's it for today's problem of the day. Thank you.